Hi everyone, this is Chris. I'm working on the ARM-DSP Bridge project as part of Google Summer of Code for Neuros Technology, and I'm going to show you a bit of my work. This is mostly what I work in, just the console, and this console. This is actually a session through the serial port interface on the OSD. This is what I mostly see of the OSD. Sadly, I haven't been able to see things like UPnP and all the other cool stuff such as the YouTube browser, because for my work nothing can be loaded. The entire Ingenian framework that runs all the video stuff has to be disabled, sadly. So this is what I work with. Let's reboot it to OSD. There, it's rebooting. As you can see, I work in Windows, but I use the virtual machine, the VMware image that CRWeb made for us. It's really cool. I can just the OSD even net boots from the virtual machine, and that's how I've been working on this project until now. And yeah, it just provides everything I need. I can build the kernel modules and can copy everything to the net booted OSD. And there, it's almost booted. Okay, let me now show you the program that's going to be run. It's in specialized assembly for the DSP. It has two functions of the library that I made. One is init DSP.com and the other is debug. Well, what init DSP.com does, it initializes the structure that is in internal DSP memory, and it just provides the communication between the DSP and the ARM, and it contains a place for a debug message and other things. Soon it will contain the location of the DEMA buffer and things like that. For now, it can just output debug messages. So what it actually does, it puts this message into the special debug position of the struct. It sends an interrupt to the ARM. The ARM catches it and prints it out via kernel print, and so you can see it on if you run dmessage, for example, just the default kernel output. And well, it will say hello world from the C509 DSP. Well, let's run the kernel module I made. It provides access to the internal memory, control, run and stop, and this communication structure. Well, there's not much to do currently. It just enables us, the display of the debug messages, which is a start, I believe. So let me just load it. There, it's loaded. Now we're going to use the user space utility that I made. It loads COF binary files. It's a very common binary object format, and it's used by Texas Instruments. So if we ever get to use one of their compilers, then we're ready for it. And currently binutils assembler can also output to this COF format. It's a specialized COF format, by the way. And so let's just load it. Bridge control. Load the program. The program is called Bridge lib test because it's the first test I made for my library and the communication structure. So there it loads the so this text. It's the actual program, the program code. Then we have vectors. It's the reset vector and all for the interrupts it might get. BSS is where the communication structure is loaded, because it's a dynamically loaded structure. And we have the stack, which is obvious, and const is where the string is. So now we're gonna load it, and we're gonna run the program, because the program is loaded now. We're gonna release the reset from the DSP, and as you can see, it immediately starts running. So we have debug message from the DSP, hello world. So yeah, this is totally awesome, you know, just as awesome as the as the YouTube browser and stuff. Well, you know, sarcasm of course. Hopefully by the end of my project I'll be able to show you much more interesting stuff. Maybe an audio codec that's being run on the DSP, or at least audio, fully controlled audio output, because currently we use the Ingeniant framework, and then hopefully we can use our own framework then for audio output. I don't see my bridge replacing the Ingeniant project anytime soon, because all the DSP side programming has to be done in assembly if we want to keep it open source. So that's quite a bummer. It's been quite hard on me. I haven't worked in assembly for a very long time. I only did small projects on it, and this is a specialized assembly at that, so it's quite hard to start with. But it's going fairly alright. It took me 3 days to write this library. And so next thing I'm going to implement is DMA memory transfers from the ARM to the internal DSP memory. And after that, maybe some other infrastructure works. I really hope to work on audio output, but we'll see how it goes. Well, that's it for now. Hopefully next time I'll be able to show you much more interesting stuff than just hello world. Good night.